Everyone, so today we are going to discuss another very important interview question, so where we have to find out v upon v in this circuit. So let's solve this. So to solve this, we are considering this voltage as vx, this node vx voltage. So when there is a small signal being applied at this terminal, what will be the current in this? That will be id equal to, we are not drawing the small signal model, we are directly calculating intuitively. Id will be gm into vgs, where gm into vg our Vn and vs is our vx. This is, you can consider equation number 1. So now vx here, if we see, will be, if we see from this terminal, we have 1 by, let's see, it is m2, this is m1, 1 by gm2 the impedance here, and 1 by gm1 the impedance looking from here. Okay, so this circuit will become like this: Vn 1 by gm 2, this is your m1 and this is your rd. So the vx, this is your vx, will be your id into 1 by, this is id into 1 by gm2. Just put this vx here, your id will become gm Vn gm1, actually this is gm1 Vn minus gm1 id upon 1 by gm2. So this will be id into 1 by gm2, sorry, this will be id into 1 by gm2. So here it will be id upon gm2. So this is gm1, so from here id equal to 1 plus id into 1 plus gm1 by gm2 equal to gm1 into Vn. So here id will be gm1 gm2 upon gm1 plus gm2 into Vn. So our v1, small signal v1, will be id id, and the sign will be negative, because whenever our gate voltage is going up, drain voltage will go down, and this is grounded, AC grounded. Okay, so we have this terminal as VDD minus ID RD. This terminal is this. Now VDD is 0 because AC ground, and this will become minus of ID RD. So just put the value here. It will become 1 by GM1 plus 1 by GM2 into RD minus. This is coming like this. Just we are changing the form, dividing by G1 on Gm2. Here it will come 1 by Gm1, 1 by Gm2 RD. So this is V into Vn. So VON upon Vn will become minus RD upon 1 by Gm1 plus 1 by Gm2. Now we have to calculate this VO2 from here. Now the same current ID, or what we can say, we know this Vx, this is, we have calculated Vx is equal to this one, ID 1 by Gm2. So here, what is the current change here? If we can say this current will be, if we say ID2 will be Gm of this is M2, this is M1 into Vg, which is ground, minus Vx. So I in the second part will be Gm2 to minus of Vx. It means minus of Gm2 into ID upon Gm2. So this the current in the second path, this path will be minus of the current from here. Obviously that will be because at this terminal both the current are 0. So we can say ID from this path should be 0. So from here as well you will see minus ID, but we are going in step by step, so we can say like this. So now the VO2 will be VDD minus ID2 into ID. Now for AC analysis this is 0, so VO2 is equal to minus of ID2 is minus ID into RD, so it will come ID into RD. So ID we can take from the above equation, which is from here, so it will be RD upon 1 by GM1 plus 1 by GM2 into Vn. So VO2 upon Vn is equal to RD upon 1 by GM1 plus 1 by GM2. So this is how we will calculate V1 minus VO2. Now actually this configuration is your differential amplifier, where we have idle current source here. So whenever we have applied Vn1 here and Vn2 here, we are grounding one, just using superposition we are grounding here and using this, and for DC analysis we make it open circuit. AC analysis for small signal open circuit. So that's how we can calculate VO1 upon Vn. Similarly we will have VO1 upon Vn2 from this path, and VO2 upon Vn2. If Vn2 is applied here, ground is here, so we can apply this will come minus RD upon 1 by GM1 plus 1 by GM2, and this will come from the same methodology. This will come RD upon 1 by GM1 plus 1 by GM2. Now what you can do, you can simply do VO2 minus V1 upon V into minus V1. If we'll put here, it will come minus GM into RD. That is how we calculate the differential mode gain of differential amplifier. So but it can be asked like this, or it can be directly asked like this only. Okay, so V1 you will get in terms of V2, similarly VO2 you will get in terms of V2, and in the above case VO2 in terms of V1, VO2 in terms of V1 in terms of V1 we have calculated here this one, and we just, so this is the differential output and differential input gain. And for common mode gain, what will be the common mode gain? We have derived it in the another video, you can see that.